Okay, today I'm going to look at the I2C bus protocol in that the smart batteries speak. This is the old battery from my ThinkPad T61. It's currently about half dead. My plan is to pull it apart and take the lithium-ion cells out of it and salvage them. But in the meantime, I just wanted to play around with it and see if I can get information from it. So I looked online and they were saying for the T40 series battery, here's the pinout. So I've connected up pretty much the same here, where I have the first two will be power, the plus side of the battery, which currently is hooked up to nothing. And then I got the serial clock, serial data, the thermistor one, which I haven't bothered to look at, and the negative for the battery, which I have hooked up to ground on my breadboard. I did find out earlier that if you are dumb enough to hook that battery directly up to the plus 5 volts on one of these nanos, the processor no longer works because it happens to be 12 volts that's coming out of it. You're supposed to put on the voltage in pin, which is the way I have it hooked up here, although I don't have this powered off the battery right now. I think I fried the processor in the other one, which is unfortunate. First thing I need to do is go into the Arduino IDE, and I have found some software online that will actually let me scan the I2C bus to find out. Come on, I don't want a tiny little thing. There we go. Which will find out what address it's at. So let's start that up, and it spits out for each address that's possible in the I2C bus. It spits out whether it found something there or not. Which is how I found out this one is at B, which is actually apparently the normal address for most of the smart battery controller chipsets. So that was good to find, and I found some other code online that I heavily modified because they were using LCD in a menu, and I just wanted to print out to the serial port. And based on all the commands that are supported in a common battery controller, which is the TI BQ 2040, it will actually, what I have it do is it'll actually print out to the serial port. Where is the code? Yeah, here you go. It'll print out to the serial port each of those values, and that will let us see what the battery actually has stored. So let's program that one in. As you can see, I'm either using the correct type of battery controller or it's compatible, because I'm getting all sorts of stuff. Right now, it makes perfect sense that the current is at 0 because I'm not actually driving anything with it. The battery is just sitting there idle. Temperature 66 degrees, sounds about right. A little bit chilly in here, but that's okay. I like it that way. Yeah, so it's saying it has a relative state of charge of 97%. It's a pretty much fully charged battery, but absolute state of charge 51%. As I said, it's about half dead, like capacity-wise. So the full charge capacity they have rated as 2 amp hours. And when you scroll down a little bit further, the design capacity is 5 amp hours. So this battery's toast as far as running my laptop is concerned. It gives me almost no time at all on it. So we got your serial manufacturer date, serial number, manufacturer name. Apparently it has Sanyo batteries in it, made by Sanyo. Device name. Yeah, it's lithium ion. I don't know what the heck BVP is supposed to mean. Don't know, don't care. And I'm not quite sure what these are, but I can look it up. I have a data sheet, the data sheet for the BQ 2040 somewhere. I just haven't bothered to look it up, but I just wanted to see what data I got out of this thing, and it looks like this is fully successful. So, next step is to take a quick break and then start pulling this battery apart. See you in a moment. Okay, for this part I'm not going to have a screencast because there's going to be nothing to see on the screen. I will be pulling apart a battery. Just unplug my breadboard here and gently pull the pins out so I'm not connected to the battery anymore. I don't have a bin for these yet. Okay. That was a successful experiment. I like that. Thank you to the internet for having useful information. Let me just turn on, in case, no, I don't think I'm going to use a microscope for this either. I'm just looking at its light on there, kind of being annoying. Let me just turn the light off. 1 second. There we go. Keeps us from having really nasty lighting there. Alright. So, to do this, you have to be relatively careful, but at the same time be like doing a destruction. So the first thing I'm going to do is peel the label off. And remember, this is a fully charged lithium-ion battery. Well, not to the original design capacity, but it is charged, and it will blow up if you do something really stupid. So, looks like there's nothing under there of use, but there might be down here, and there might be a seam to get at. So I'm going to continue peeling this off if I can get at it. Unfortunately, without nails, it's really hard to do this sometimes. So, hence the blade. Doesn't look like this is going to be give me any good here. Okay, changing plans. Looking at it, there is a seam right up the side here. Right up the side along here, there's a seam, and I guess it goes all the way along the front, and then all the way along through here. So let's get medieval on this thing. Yeah. Thought I had a flathead screwdriver around here somewhere. Doesn't look like I do. Alright, well, this may turn out to be a little bit more interesting than I expected. Let's get in there with a X-Acto knife blade, maybe. See if we can pry this apart just a touch. There we go. You know, they didn't really design these to come apart, so sometimes some companies do better jobs than others of sealing these things permanently. It looks like this one's actually fairly well sealed. But I know that this just contains a bunch of 16850s, or is it 18650s? Whatever. 18650s actually, I think it is. So they're just normal. You can actually see the, yeah, if I get under the camera, you can see the bulge of the bump there. Those are the cells, the actual cells inside it. So I know approximately where the cells are, so I should be able to do this without having to worry about actually hitting the cells. So but since I replaced this battery already, which is what the laptop is currently running on, is a new battery, I don't feel badly about destroying this one. Can always use more lithium-ion cells anyway. Come on. One thing I don't want to do is break the X-Acto knife blade. You can actually see the edge of a cell in there. There we go. No battery is more persistent than a destructive engineer, so ouch. Ooh, he's gonna get himself hurt if he's not careful. And I finally got this to rip down that seam, so alright. That's what I wanted. Tear that puppy right apart. This thing zoomed all the way out. Yeah, it is. Okay. Alright. There's one side of it gone. My trash bag. Trash bin there. Alright, now let's see if I can get this out of here gently. Gently but firmly. You know. Two-sided tape. Is that all? Hey, come at me, bro. Okay. Now, as these start to pop free, I'm actually going to cut the interconnecting things that's holding the cells together, so I don't have a great big floppy six cell monstrosity sitting on my desk. I actually want individual cells, so let's just... That briefly got warm. Wow. It did not like me cutting on it. This piece here got really warm really fast, so I snipped it. Now it is no longer warm, and the chances of it blowing up is gone back down to 0. That was not what I had in mind. Like a good freak out once in a while. You can see these batteries here are connected to each other. Now, if this thing cut properly, I should be able to complete this batch of those. There we go. There's one pair. And disconnect this from the charging board. There we go. And same here. Snippy snippy. And wow. There we go. Alright, now one set left to pull back out. Ouch. Of course, I put a nice sharp edge on there for me to cut my finger on. Come on, come out. Oh, the charging board came out too. Alright. There goes the back. Let's get this two-sided tape off of it. They did a good job of insulating the end of the battery, though. That's good. Hey. Yeah. You see right there, that little yellow thing is the thermistor. It was pushed right up against the battery to get the heat of one of the batteries at least, which is kind of cool. Let me just cut this board off. And there I was thinking I didn't want to use the microscope. Okay, well, we'll take a look at this board under the microscope in a few minutes. Let me just get this part done first. Come on. Come off. These side cutters aren't particularly good. There it goes. Yeah, there's the board. And there's a pair of cells. And I do not want these cells in pairs. And why don't I have my headset on? Idiot. Okay. I think we'll be going off the video camera's audio for this one because I had my headset off the whole time. I'm an idiot. Alright, let's get this tape off of here. You can see that they have them connected directly together. This was a six in series. No, 3 in series, 2 parallel type of pack, it looks like. So I don't want that. What I want is 6 individual cells, which I can then measure to see if any of them are still good. Which I'm sure some of them are, because it was holding half total charge. So I'm expecting, if we have any dead cells, it'd be like one set maybe, might be hosed, I don't know. First I've got to get them all out. Let me cut that long piece off. I don't really need that on there. There's that long piece. Alright. Makes his hands rather sore using these cutters. But, you know, nothing doesn't come at a price. Take the tape off in this. Another extra gasket, whatever the heck this is. Okay. 2 more cells. Alright. It's got a nice long piece here. Alright, and again, take the tape off. It's okay. Come on. You can do it. Come off. There we go. Another gasket or whatever this is. Alright. So use trimming. Ouch. But they're out. Just clean up these little pieces, throw them out before I stab myself on them. Because some of them are rather sharp. Into the box of trash. Okay. Next step. Oh wait, that's upside down. I keep forgetting I'm recording upside down. How's that? That work? Yeah, I think that works. Okay, make sure these are all the way plugged in. Alright. Now, this is the positive end. That's the negative end. Now, either I'm doing this wrong, or I found the dead cell. There, that's better. 4.02 volts. Okay, that one's definitely not dead. That's actually pretty good. So I expect this one should be the same because they were tied together in parallel. Yep, 4.02. Now for the next pair, 4.07. Again, these things are nominally 3.7, so we're doing pretty well. Surprised this thing shows up as being half capacity. Unless it's these. 4.13. Okay. Well, I guess they're just a little bit pooched. But whatever. Once I actually get the proper tester for them, I can run them through and see what their actual capacity is. I was planning on getting one of those eventually. Put this away. Alright, now I foolishly did not start up the microphone. So let me just quickly get that up. So just want to take a look at the charge controller board that we just pulled out of that battery. Alright. Don't know what these little buggers are. Probably look them up, but this is what's in there. There's the thermistor in the package there. And there's the battery controller, which apparently is the newer version of the BQ series. It's obviously compatible with the other one because, yeah, it read out the information I wanted to know. And that one, I believe, is the actual charger chip. If I remember correctly, they come as a pair. There's our connector way down at the end. And on the other side, not a whole lot. Kind of as expected. A couple little active components in here. Some resistors, a couple diodes or probably capacitors. That's about it on the back. Huh. Well, there you go. I have a few of these sitting on my desk at work too. I ripped out other batteries. It's nice to know I was actually able to read from it. Okay. So, we started off with a laptop battery, and we end up with 6 more lithium-ion cells. I mean, yeah, they got nasty metal on the end of them that I need to deal with later, but that's okay. I already have a box of these, so I'll just add this to my collection. Just get the box out. Let's underneath the monitor. I got a box that, whoops, of ones that I had done the same thing at work. We have 6 cells there, light blue. We have their Samsung cells. I have 6 dark blue cells here, which are, I'm not sure. I think they're Panasonics, but it doesn't say brand name on it. And then I got some flat pack ones as well. Those are GPCs. So if I can find enough space in this box, let's add some more batteries. I want more batteries. 2 more. Do they fit over here? I mean, yeah, these do need trimming for sure. I'll put them in the box. The box is not going to close properly. But close enough for now. At least get some out of the way. Because when you got 3 cats around here, anything you leave out is suspect to be thrown on the floor. Alright, I guess that's it for now. Ta-da.